I have a knack of stretching my vocal cord, but doesn't mean that I've lost my vocal cord.
Yes.
Okay, so we get started then.
Yes, sir.
Lisa seems to have lost her voice. Good evening, dear. Yeah, finally you got your discovery voice, the vocal cord, right, dear? So we get started. Okay, enough of being cheeky. These are the ones which we need to be careful about when it comes to the property or the property subtracting. First one is an aid, second one is an opposition. I presume it's visible. Do check.
So could you flip the orientation?
Yeah, I'll come closer just a minute. Okay. Look over here. This one. This is a diagram. Current enters from here. It goes in the loop. Okay, it comes out this way. Then it enters the other one, goes this way, and comes out here.
Could you flip the orientation? It would be utilizing more of a screen space if it's landscape.
From here, it enters from here. It loops around. It comes out from this one, goes this way, loops around, and this is the point from where it exits. I'll mark this point. This is, let us say, A. So it is making an exit from A and entrance from B. Is it okay?
Yes, sir.
Both of you on this. Now, this is being presented this way by a schematic diagram. This is a presentation by a schematic diagram. Look at the dots, please. Take care of the dots. They are side by side, indicative of they being in opposition to each other. It is based on direction of current. Please do check. In this one, current is flowing this way, whereas in this one, current is flowing this way. Go by direction of current. This one, current is flowing this way, that is to my left. And this part, current is flowing to my right. And then look at the dots here, side by side. Of course, they are in opposition, flow of current in opposition. So they are to subtract. Over here, they are to subtract, operation, subtraction. Then coming to the second one. You see for yourself what in second one? Direction of current maintained, correct? Here for this one, it enters this way, direction of current to my left. It comes out here, this point it comes out, it goes back to it. Again, direction of current to my left. Okay, present it. This is the one. Dots. Do check the dots. It's getting reinforced over here, additive. In the previous one, it was attenuation. In this case, it is accentuation.
So the second case would be the plus 2m case, and the first case is the minus 2m case.
Correct. Another example which can be cited over here. This is addition of same direction of current. You can show in terms of flux as well. Okay. This will be this one, flux. Same direction of current. And over here, opposite direction of current.
So if they go out of their way to make the current direction opposite, we've got to assume like they're opposing each other.
Yeah. Okay. Correct. Just to cite an example, an exercise example, this is the one. Here again is an opposition, so they are to nullify. If the exact value is being maintained, they are to nullify, else will oppose each other on both the fronts. Are we through it? Vasudev, is it with clarity now?
Yes, sir.
Clarity and clarity both, correct? Not one over the other. Clarity and clarity both, correct?
Yes, sir.
Okay, I hope my voice is not muffled. Okay. So this being the one that I wish to take in order to be more apprehensive about it not cutting through, as is not being dealt in general, we skim through the surface when it comes to time management with the coaching institutes. So I'm not rushing through this important topic. Please see to it. If you are through, I may flip page. Ashita, is it fine? Is it good with you? Ashita,
Yes,
is it
sir.
good with you? Are
Yes,
into a
sir,
siesta over here?
Muffled, so I'm just trying to understand. I heard in between current is coming from here and then how it is in
Okay.
opposition
Are
or
you
not.
able to make it out? Yes or no?
Yes, sir. I'm just trying to
Okay.
connect all of it.
Okay, good enough. You can reconcile and you can be able to, I presume, decipher whatever we have elucidated over here. Okay, moving on in furtherance with what we are. Let us go for oh, by the way, I got reminded on the question, Vasudev, that I did furnish. There, you said that you are not very comfortable or not comfortable per se with LC oscillatory circuit, right?
Yes, sir. So, but
Before I get
I'm yet
yeah.
to study that by myself. So I'd like to put off any discussion on the topic until I am through it by myself. So I mean, it would be more useful for me.
Point taken. So what are you through? Shall we take that part? What portions are you through? Shall we reinforce those parts?
So we could continue from where we left off last class. We were doing reactants.
So we were into reactants, correct?
Yeah.
Let us now combine. I took definite cases, if I remember it correctly, memory serving good. Then I took definite cases, the case being ideal inductor, ideal capacitor, and ideal resistor, right? We took 3 cases.
Yes, sir.
We calculated VAB across their ends, and just to connect the dots, here we got it as Q by C. Q is IDT by C, and then we integrated assuming current to be a function of sine, trigonometrical function, correct?
Yes, sir.
I not sine of the angle omega t dt integration by C,
So
which is
could
what
you
got us.
please flip the orientation? I mean, it's quite hard to watch the entire thing with your head on your side.
Better now? Any good?
Yes, sir.
Okay, so I done. Omega c is what we got, cos of the angle omega t with the negative sign, right?
Yes.
And we got to know from there that we can take I omega c, we can write in the form of sine of the angle 90 minus omega t or 90 plus omega t. We decided upon one, right? Which
Yes,
one
sir.
we decided upon? I presume 90 plus omega t, and accordingly got to know that which one is to lead which. By the way, we can take minus sign inside, we'll have to take. So I'm writing both for you. This is the minus sign out. And the other one is sine of the angle omega c, sine 90. Sine 90 minus omega t will get me omega t minus pi by 2 if I'll take the negative sign in, right? Do you check the two? In first case, negative is out. In the second case, I have used sine 90 minus omega t for cos omega t and minus being incorporated, which is to get me I by omega c sine omega t minus pi by 2, correct?
Yes, sir.
Of the two, which one we should go with? The one which is getting us rid of omega t. So we go with the second one. And second one is indicative of voltage lagging by pi by 2. Lagging by pi by 2 in which circuit? Capacitive circuit, purely capacitive circuit. And lagging vis-a-vis which physical parameter or physical quantity, that being current, correct? So in a purely capacitive circuit, voltage lags current by pi by 2, or if you have to rephrase, current leads voltage by pi by 2, correct?
Yes, sir.
Okay. Purely resistive circuit, they are in phase. Purely inductive circuit, what was the inference drawn? Please come with it.
So the opposite, the current leads voltage by pi by 2.
Okay. By what quantum? Pi by 2.
And
what
resistive
quantum?
circuit, they both of them are in phase.
Yeah. Correct. So what next? I'll be clubbing them now. They were individually studied. We got to know that the phase difference between current and voltage will be of pi by 2 or 0. Pi by 2 against which parameter and 0 against which being known to us. Let's try to club them now. So I'm going first with RC circuit, RC or RL. This L is known. So let's go by RL circuit first. RL circuit, please do check. Current being fed to it. What is current being fed to it? Of course, alternating. I max or I naught, sine of the angle omega t. Visible?
Yes, sir.
Visible? Okay. So I max sine of the angle omega t is what we get. After this, what we had to do, we had to calculate potential difference between these 2 points, this point and this point. I'm marking it as AB. So we get VAB is equal to VA minus VC plus VC minus VB. Right, dear?
Yes, sir.
VA minus VB will be, VC will be how much to us? I, the current, into R. I'm writing it as I here. I is equal to this to me. It's a function of time, of course. IR plus, what do we get for this quantity, dear? I multiplied with XL, right?
Yes, sir.
Okay, now tell me, what do we get then? I max sine omega t into R. And what was for this one? I XL. What we got? VC minus VA individually as. What did we get? VC minus VA individually against the inductor. We got what factor? Tell me. I into omega L, correct?
Sir, one second.
What was L di by dt? This one we have calculated as L di by dt. Can you recollect?
Yes, I recognize that.
Okay, so L as it is, what was di by dt? What will we get from here? Di by dt? We'll get it as omega, right? Sine of the I max, sine of the angle omega t. Do check. I'm just writing what we got individually over here, nothing much. What got individually? L di by dt. What will be L di by dt? L is this and I is this for us. So differentiated with respect to time, what do we get? I max omega cos of the angle omega t, correct?
Yes, sir.
So I max omega cos of the angle omega t. I'll go by phasor later. First the organic, which is the quaint one or the archaic one, you may say. You may say it is antiquated process that I'm going first with. So be it. No qualms about it. This is more of an import as this will never fail you. The other can occasionally be an onerous ask, very taxing. So R sine of the angle omega t, okay, plus Max is out. So omega L cos of the angle omega t. Fine, yeah?
So 1 second. L di by dt is equal to IXL, right?
Yeah, IXL, correct. Where I is it?
Okay, alright.
Okay.
Yes, sir.
Is it fine? Now, what can we do over here is well known to both of you. What do we do? R square plus omega square L square under the root is what we divide and multiply with, correct?
Yes, sir.
So let me do the other way around rather. I'll multiplication, I'll be taking it out. So I max is as it is. I'm writing for this, I'm writing in this time go. Let me write it down. This time, as far as this time go, I'll write it down. Later I'll be using Z for it. So R divided by this factor Z sine of the angle omega t plus omega L divided by Z cos of the angle omega t. Figuring it out? Z is what to? Z is this factor.
Yes, sir.
So I max into Z now all. What do we get? Sine of the angle omega t. I'm treating this as cos, then this will be sine, right?
Yes.
Cos alpha, if this is cos alpha, this will be sine alpha, correct?
So omega t minus alpha, so omega t minus alpha.
Yeah, we'll be getting as omega t plus alpha, right? Plus.
Yes.
Do we have plus over here? Or
Okay.
I think it's plus.
It's plus. Omega t plus alpha.
Omega t plus, yeah, plus alpha. Omega t plus alpha is what we get. Where tan alpha, customary to write, as one can take any part. I can take the other way around. This can be sine alpha, this can be cos alpha. So it's mandatory or incumbent of us to write what is tan alpha. In our case, it is omega L by R. Check please. Right?
Yes, sir.
So what do we get from here? What is the inference drawn? The inference drawn being, which one is leading here? In RL circuit, which is to lead? Current or voltage? This is voltage equation, by the way.
So
and it is getting omega
t plus alpha.
right?
So voltage is leading, obviously.
Voltage leading current, obvious, and leading by what quantum? Alpha. Alpha is what to us? Tan inverse omega L by R. Okay, which can be marked also as XL by R. Very important factors here. Very important factors. These are to extrapolate what will be getting in LC circuit later. Okay. Where am I? I'm visible or not? What happened? Yeah. This is fine?
Yes, sir, fine.
Would you please, the two of you, help me with RC circuit quickly? Tell me, if I'm to take a Q from here, what do I be getting? If I take a Q from here, what do I be getting in that case here? RC circuit.
What
do I get there?
Here we, in an RL circuit, I mean, the inherent property of L is to have voltage lead, and we've combined R and L. We've kind of got an intermediate result. R tends to keep them in phase, and L tends to have voltage lead, and we got something that's between them. So you'd expect the same for an RC circuit. Their voltage would lag, but by a phase difference less than pi by 2.
So can you extrapolate Z value there? As we got Z here, can you get me a writing for Z there for RC circuit? What would we be getting there? What would we be getting there in RC circuit? Can we? Just drawing
Yes.
a parallel will get you there.
So
Instead of LTI by dt, what you have to place, you are aware of it. There'll be a minus sign, I presume. Between the two, there is going to be a minus sign, right?
so
You
why?
want to check. Check. What are you getting? What did we get? Q by C as. Voltage will be Q by C, and Q
Yes.
was marked as IDT. And IDT, what we got was I max sine omega t with a negative sign divided by omega c. Do check. Depends on which factor you're taking out. Was it not I max by omega c sine cos of the angle omega t? Do check, dear. Was it this? individually? No.
So 1 second. So basically, the resistance part would remain the same. That would be IR, right? And for the capacitor, we would have plus Q over C, right?
Right.
Okay, so that it is plus Q over C, no minus that.
Okay.
Um,
Q will be IDT,
yes.
which will
IDT.
get you the sign.
Okay, so if we integrate sine, okay, we'll get cos. Fine. All right.
Okay. What do we get then? Z as? Come on, tell me. In this case, what will be Z? Let me remove this part. Yeah. We do the same mathematical manipulation, which is what to us? Imax taken out, right? This time R square plus 1 by omega C whole square all under the root, which I'll write Z, correct?
Yes, sir.
R by Z minus 1 by omega C Z. First one is with sine, second one is with cos. This is with sine, and this one is with cos. Right?
Yes, sir.
So Imax Z bracket open. What do we get this time? Sine omega t minus of alpha, correct?
Yes.
Well, what is tan alpha? Tan alpha is what to us? 1 by omega C R.
Yes.
Okay, so this is what we do get. And what is the inference drawn? Voltage will lag current or lead current. In this case, RC circuit.
At lag.
If voltage will lag current, or in other words, current will lead voltage by what angle? Alpha, where alpha is tan inverse 1 omega CR. Inverse of omega CR. Correct?
Yes, sir.
Okay, is it fine with you, Ishita?
So can we also say that as the resistance decreases, tan alpha tends to infinity, so alpha approaches pi by 2, so it becomes more capacitive?
Yeah, of course.
Yeah.
It will fall in the domain 0 to 90, correct?
Yes.
For clubbing, wherein we are taking a dual, it'll fall in the range from 0 to pi by 2. Got it, yeah? I'll be drawing the graph for you, don't you worry. Okay? We'll be checking the graph. Let's get completed first. Okay, so now, all in tandem, in one go. Let's take all the components, electrical components. We know only 3 components in electricity, electrical engineering. R, L, and C. Let's take all of them, clubbing them together. RLC, you say, either we say an LRC circuit or an RLC circuit, whichever way you call. Order is not much to pay as of this point in time heed to. Okay, so this is the one. What we are going to do is quite mechanical, nothing much. VAB, tell me what will it be. First will be Imax sine omega t into R, first part. Then we'll be getting minus of Imax by omega c, and this was cos of the angle omega t. And final plus of Imax omega L, again cos of the angle omega t. We checked it. VAB what to us? Imax can be taken out. We get it as R sine of the angle omega t for this part. And what do we get from here? Omega L minus 1 by omega c. Back to the same form, right? Yeah.
Yes, sir.
So what do we get? Imax. We can write Z over here. Bracket open. Sine omega t plus of alpha. What is Z? Z is R square plus omega L minus 1 by omega c whole square under the root. right?
Yes, sir.
What about tan alpha here? Will be tan alpha is also an obvious. Omega L, omega C.
divided by R.
Now there's one caveat we need to be careful about, and we cannot just by the equation formation get to know on which is to lead, which to lag. It is subject to XL, XC value. If XL is greater than XC, obvious which one will lag is known to you. Because then what will be more on reactance is inductive than capacitive. If we take XL greater than XC, inductive reactance is to occult capacitive reactance. So it will be more of inductive reactance to call shots then. And what we get to see in that case is very much ambivalent to what we were trying to infer, and that being voltage will lead current, correct? If omega L is greater than 1 by omega C, then this factor to us, this factor tan alpha to us will be positive. If tan alpha is positive, then from this equation we can say voltage will lead current, correct?
Yes, and if they're equal, it'll only be a purely resistive circuit.
Well, then it'll be a purely resistive circuit. That is what is termed in engineering resonance. Remember, what does resonance mean? When a circuit behaves purely resistive, which is possible only for the cases when all are clubbed, correct? So when the circuit acts purely resistive with all the components of electrical circuit present, we say circuit is in resonance or exhibiting resonance. It acts purely resistive. Getting it here? It acts purely resistive. And when you are going to get it? When omega L is equal to 1 by omega C. When omega L is equal to 1 by, so what is omega from L? Let me write it down for you. 1 by LC under the root. This is called a resonant frequency. This is called a resonant frequency. Am I clear?
Yes, sir.
Okay. Get me a plot now. Of course, when I say, by the way, let me ask you before I'm getting plot from you. When I say circuit is resonating, then Z will take shape of R, correct?
Yes.
And if Z becomes R, then current is maximum, isn't it? Maximum value of current, if I take Imax, what I get to see, Imax will be written as VAB by Z in general. Imax will be written as VAB by Z, agreement?
Yes, sir.
Okay. So if you are in conformity with Imax can be written as VAB by Z, then that Imax will have its maximum value when Z is equal to R, which is to say when circuit is in resonance, correct?
Yes, sir.
That means equal to
Yeah.
X.
Yes. Yes, sir, tell me. What do you want?
So that
What
means
do you ask?
XL would be equal to.
Yeah. Z I have not named as yet. It is named impedance. We call it impedance, the combination of resistance and reactance. Reactance itself has got subdivision, inductive reactance, capacitive reactance. So Imax will take its maximum when circuit is resonating, which is when Z is equated to R, and Imax is VAB maximum by R. Now a question coming your way, can I get plot of current versus omega? Can we get plot of current versus omega? This omega is customary written omega f or omega resonance, omega r, resonating frequency.
So you mean Imax as a function of omega?
Yeah.
Okay.
Triplot both of you. So you get the current maximum over here. This is the current at its peak when omega is equal to omega r, let's say. Let me ask you, before of reaching omega r value, how is the circuit acting? Is it acting inductive or capacitive? Because at omega is equal to omega r, it is acting purely resistive, that you're aware of. Before of omega is equal to omega r, very simple question. How is the circuit to act? Capacitive or inductive? It's
So
no
if
brainer, by the way.
omega is less than omega r, omega is in the numerator for XL, so the inductive nature would be less, so it would be more capacitive.
So we can take it this way then. Omega square is less than 1 by LC, right? So omega is less than 1 by LC under the root, correct? So omega is less than omega r, and that happened for the case when this was greater than this. That means to the left it will be capacitive, correct?
Yes, sir.
And to the right of the peak, it is inductive to represent. What will it represent is the question. So it is inductive nature to represent. Clear?
Yes.
Sure? Okay. Now on the phasor term quickly. By phasor term, what I mean, pretty simple. You will get in one stroke every that you have figured out over here in piecemeal, you'll be getting in one stroke. What we have to do, we have to draw a phasor diagram. This for me is voltage across, let's say, resistor. We know that V across inductor is marked as L di by dt. Please pay heed over here. It's an important point coming your way, which is omega L I max, because this will not be dealt. Sine of the angle omega t is what we got. Please check. Sine of the angle omega t is what we got. Omega I max, sine of the angle, sine, or change to cos, sorry. It's cos of the angle omega t we got. Let me change over here. Which we wrote as, I write it again for you, omega L I max, sine of the angle omega t plus pi by 2. This is what we wrote. Look at the incept, please.
Yes, sir.
This in Euler form, what do we write is, omega L I'll treat as it is. And we are in a form which is Euler. By Euler, what I mean, you must be aware of e raised to the power I theta. How do we expand, correct?
Yes, sir. Cos theta plus I sin theta.
Okay. Now, it's a tad bit indecorous of us to write, but we do in physics. Instead of writing sine omega, write imaginary of, we can do the same over here. Omega L taken, I max taken. And we can write imaginary, which is written this way to begin with, and later you will be adding to your rows by dropping it. I'll come to it later. Now, what do we do over here? E raised to the power this imaginary of which part? I bracket open omega t plus pi by 2, correct? Check the Euler form. Let me write it down over here. Omega L I max imaginary of which term? E raised to the power I omega t plus pi by 2, right? Is it good?
Yes. Okay. All right.
And then yes, not good. Okay, again then omega L I max. Now to add to your woes, what I'll do, I'll drop imaginary. That is what they do. When they write it as e raised to the power I omega t plus pi by 2. So omega L I max e raised to the power I omega t, and to that e raised to the power I pi by 2. Correct?
Okay, so what's the point of all of this?
This is to tell you why is it oriented by what angle. Now what will this do? This is phasor diagram, right? Yeah. So it will rotate it anti-clockwise. It will rotate this part. This is the part which we are having. This part will be rotated by what angle? Pi by 2 is what it is indicative of. Correct? Yeah.
Yes, sir. So
This phase got rotated by what angle? By 90 degrees. So it is being represented over here.
this is basically just another way of saying that voltage is always pi by 2 ahead of current.
In this case,
I mean,
Okay.
it sounds like a bit of overkill to I mean use this to just.
Clockwise. Basically, we refer from here anti-clockwise, clockwise, and we are into phasor. So we'll have to factor in mathematics.
Okay.
How will you represent the device without using the concept of phase? You cannot utilize in physics. You have to first make clear to student that yeah, this is a phasor diagram. You cannot willingly start with this is the one, this is the direction. Since they are known to mathematics over here, you can play around. But when you are in class where phasor or complex numbers were not being taken as yet, you have to deal with it. That is the work of a physics teacher. Now what do? It goes this way, right? And what is this to us? I into XL, right?
Yes, sir.
Resultant then will be this to us. What will this be? I bracket open R square plus XL square under the root. Do check. Which is nothing but Z to us, correct?
So just a second.
This part, this is what I was referring to. I bracket open under root of R square plus XL square, right? You check.
So IR is the potential difference across the resistor, and IXL is the potential difference across the inductor.
Yeah, they are at a phase of 90 degrees with each other, right? Because here current and voltage are in phase, but over here current and voltage are at what relation? Pi by 2, correct? This is current and this is voltage, right?
Yes, sir, but how can you justify adding them vectorially like this? I mean, the mathematics work out fine, but I mean, what's the intuition here?
The intuition over here is pretty simple there. When current is in phase with voltage, I'm drawing for voltage across resistor, correct?
Yes.
And I know the current is in phase with it. So current and voltage, this line represent either current, you can take the reference as current, you can take the reference as voltage. I don't have any qualms. If I take voltage over here, then voltage across inductor should lead. Lead by what angle? I by 2. Should lead what? Should lead, either you say voltage across resistor or you say should lead current. It's the same, right? This is the reference line, correct?
Yes,
so that lead will be shown by moving anti-clockwise. I have moved anti-clockwise.
So just one second. What does the result of these of the vector addition of these two indicate? Really, what does it represent?
That will represent the voltage across 2 points, A and B, as we took. You can reverse it. You can make this R and this L. I took first across this one. VA minus VC is this. And CB was at an angle 90 degree. So at an angle 90 degree, And when you ask for the totality, it accrues to voltage across AB. That is what it is accruing to. The amalgamation is getting me, this is the resultant, this is the phasor diagram, this vector to me. What is a phasor? Yeah. That is the reason I took this, to make you understand. We keep on speaking phasor. What does it mean? Basically, it is a vector which is rotating. It is a vector which is rotating. And that you can see from here. This is a vector which is rotating. But I have taken this particular term as reference, correct? That means I'm moving with vector. I'm rotating with vector, correct?
Yes, sir.
In that case, to me, rotation will not count. What will count? Is pi by 2. And that is what is counting. It is not stationary, it is rotating.
Yes, sir. So, and while it is rotating, we always only consider one component of it.
Yeah, of course.
Okay. Right. So, right now, I r squared plus, okay, so I r rotates on its own, right? I xl also rotates on its own, right? But they always remain mutually perpendicular to each other. And their respective components on whatever axis. I mean, on which axis are we taking the components again?
We're taking in the complex plane, yeah. I and Z. R, if you ask me how to write Z, then I'll tell you Z can be written as R plus JXL. It's a complex plane.
Okay. So basically, we're only considering the imaginary component here. We're discarding the real part.
Yeah, correct. Yeah, correct. That is what I wrote over, right? We are dropping imaginary.
Okay.
But we are going with only imaginary factor, correct?
Yes.
Getting it?
I think I'll have to let this simmer in my head for a while.
It'll sink. Will not move surreal. Let us get a record time to it. Let's check it. Is it fine with you or not? I'll wait for the time. I'll wait for the time you take to sync. Take this concept to sync. Ishita, are you getting it? Ishita, may I have you here?
Yes.
Okay. And not only that, Vasudev, you can check for what we did find other way around. Alpha. What is tan alpha? Tell me. Tan alpha from here, XL by R, correct?
Yeah.
XL by R, right? So we get that, and we get the leaning as well. By leaning, what I mean, what kind of circuit it will be? The direction it leans. It is inductive circuit, correct?
Yes, sir.
Leaning to the side, right? It's an inductive circuit in which voltage leads current by what angle? By angle alpha, where alpha is tan inverse of XL by R or omega L by R. Correct?
Give me 1 second.
Sure. Please do.
So, okay, fine. I think I got it. So what we are saying is, if we individually take the components, in the imaginary components of IR and IXL, that would be the same as taking the component of the resultant, imaginary component of the resultant, of course.
That is the essence of phasor diagram, right, dear?
Yes.
See, we have three phase. When we call three phase, then one is leading the other. We know that. And what we do is we make the rotating frame per se reference by dropping the omega t term and then comparing one with the other. That is what we do, correct?
Yes, sir, fine. Okay, I get it.
At home also you get three-phase connection. You must heard of the term, right? I'm having two-phase connection, I'm having three-phase connection, right?
Yes, and I haven't heard that bit of terminology.
Okay. So in current voltage, dear, let me ask you then. The circuit that you do have at home will be either inductive or capacitive, right? We can never get purely inductive circuit. We can never get purely capacitive or purely resistive circuit. So we'll be having combination of all the three, right?
Yes.
So when you write current, when you write equation for current at your place, wherever you are as of now, you write equation for current. So in that current equation, voltage and current, which are to feature across a socket, they will have a phase difference, right?
Yes.
They will not be in phase. They will have a phase difference. There will be a phase difference between current and voltage. One will lead the other, of course. You know what? Correct?
Yes.
Okay. Then, what do we do
Sir,
over there? Why is there? Yeah.
sir, then, like when we say so omega t plus phi, if we write, so that's the phase basically.
See, there are more cases than one. You will be encountering inductive circuit. You will not be encountering a leaning capacitive circuit, because generally the electrical load, whichever load you take, AC, you take an AC operational, you take a fridge operational, you take an inductive circuit operational, you take a heater operational. What are they? They are generally inductive load. That's the reason we deal with fan. What are they? Any which is having coil will be inductive in nature. So when you take inductive circuit, voltage will lead current, we are aware of it. In more cases than one, we have to encounter a situation back home where voltage will lead current. Then it comes to us, what is to be done against capacitive circuit? Where do we encounter capacitive circuit? Do we have capacitive circuit also to encounter, or it's always inductive or purely resistive too? Capacitive and general you don't have to encounter there. Then why on earth we are studying about capacitive circuit? We're studying about capacitive circuit because we need to reduce, I repeat, we need to reduce angle between voltage and current. Whenever is required to reduce angle between voltage current, we take help of, or we find resort in, a capacitor. Capacitor therefore is reduced in the operation that we are to study now. Capacitor is reduced, or the work of capacitor boils down to reducing angle between current and voltage. You may then ask, why am I hell-bent on reducing angle between current and voltage? I'm hell-bent on reducing angle between current voltage because by executing this reduction, I can increase power supply to my circuit. I repeat, I can increase power supply to my circuit. Take it on face value, because in few minutes from now, we'll prove how is voltage, power, current, and phase between them related to each other. Fine, yeah?
So basically, you're coming from P is equal to VI. So if V and I are in phase, both of them reach the peak values at the same time, we'll get the maximum power.
It is not, it's a bit beyond it, as it depends also on the angle between two factors. And not only that, you will be surprised to know that it can be negative as well. But for now, let us come back to it. Is this good with us, the phasor diagram?
So, does it have any leaf over, because it allows AC to flow and it will not allow DC to flow, that's right?
Capacitor.
Yes, sir.
Capacitor is also used as filter. That is another work of capacitor. It is used as filter, but that is used more. The filtering property is more to be used in electronic circuits, not in electrical circuit. Right, dear? There we filter out direct current by uses of capacitor. Okay?
C is infinity and F is 0 at least.
There we use in electronic circuits, not here. Here that doesn't merit. Okay. Now, what about phasor diagram vis-a-vis capacitor? I presume you know, right? That case will be down, right? IR, the reference, will be down, IXC, right?
Yes, sir.
And then you will again connect, you will get that result. When all the three are applicable, then what kind of circuit you will be getting, that also is very much viable for you now to plot. depending upon which is to dominate. If I say XL is to dominate, you'll be getting it this way. This part will be then I bracket open XL minus XC. This is IR, and you get to see this as alpha. Tan alpha will be what to us? XL minus XC by R. And this will be I into Z, where what is Z you know. Z will be R square plus XL minus XC whole square whole under the root. Do check this. Right? Now please see for yourself, what did the capacitor do? Did not decrease the angle between total voltage and reference voltage. Yes or no? The angle was this. If I add capacitor to inductive circuit, what will it do? Resultant, let us say now, is this. So what it did to the angle, from alpha it got decreased to beta, right?
Yes.
Yes or no? So what is the capacitor to felicitate over here? Capacitor is to felicitate decrement of angle between resultant voltage and current. Can we say that? Can we make that statement? Subscribing to it, yes or no?
Yes, sir.
With the help of capacitor, we can decrease angle between voltage and current. A very important function of capacitor. And what is this to gain? You'll get to know. What is the decrement in angle to gain? We'll get to know. So from here, I take a leap to power. What is power? You're aware of power means product of voltage and current, right? Yeah. What is power to us? Instantaneous power is what I'm referring to, product of current and voltage. So I max, sine of the angle, let us say omega t, is current to us. And voltage is V max, sine of the angle omega t minus alpha. I'm taking voltage to be lagging over here. This is current and this is voltage. Do check. Fine?
Yes, sir.
Some angle, they are into sharing. No issues. Right, this part can be negative. Now see, a circuit is consuming power means source is providing power to the components of circuit. Correct, yeah?
Yes,
A
sir.
circuit is consuming power means source is providing power or energy to the component that the circuit is comprising of, right? So energy is being consumed by circuit. So yes or no? That is what it infers. Energy provided by source is being consumed by circuit. Is it possible that circuit reflects energy to source? Possible? Is it possible?
So, sir,
That
alpha will
instead
have to
of
be
source
obtuse.
providing energy, circuit is providing energy to source.
Yes, if
Instead
they're
of source providing
perfectly out
energy,
of phase,
circuit is
then yeah.
possible?
Yes, sir.
Very much possible, and that is what is negative. But there is a problem that I do have over here with this concept, Vasudev. And the problem that I do have is source has got a dog belief that it is circuit to parangle around and the source is the provider. So source is deeming it to be the provider. Will it be able to come to terms with it being an acceptor? Instead of calling shots, it is being come to term. So now circuit is setting term to source. Will it swallow it?
So I suppose it depends on the source.
Exactly. And this will be something which we will have to manage, because source is not used to reflection of power or to consume power. It will not swallow it. Egoist, or you may say this assuaging of its ego. It is not to accept. So what we have to do, we have to ensure that this power doesn't reach source. Whatever power, whatever energy is reflected by circuit should not make its way up to the source. So how can we arrest? How can we ensure? Because power will be negative. You're aware of the function out here. You will get power negative as well. So how will arrest reflection, or how will arrest that reflection to make its way up to source? There is only one way out, which is what? Exhaust that energy, right?
So wait, I have a couple of doubts here.
So exhaustion is possible only by uses of register, correct?
So could I?
That is the only element.
Ask something?
Yeah, please do.
Right. So, first of all, if the product has to be negative, so what does it even mean for a circuit to, revert power to its source?
Let us say there is a train which is moving uphill.
Okay.
Now it has started moving down the hill.
But that wouldn't mean that the wheels turn the engine, somehow it produces cold, right?
No. It's not to be a catastrophic move there that the engine started moving backward. That is not the case that I'm telling. That's the reason. That's the reason over here we need to ensure, otherwise it will happen. That's the reason over here we need to ensure that the power which is reflected should get a vent. Else it is to damage source. Will it not?
Yeah, I suppose.
It will damage source. It will make it rotate the other way around. If the source is rotating clockwise, it will instill that it starts rotating, or it will dampen the speed. It will be exasperated. As we say, it will be flagging. To avoid exaberation, what we need to ensure is this never make its way. And it cannot make its way only by one component, which is to come to our rescue. And what that? Register. That is the reason we need to design exact register value whenever we are into assembling a circuit. We need to know. That is how we assign resistance value to a circuit. Otherwise, why on earth we are to add a component which will reduce efficiency of electrical circuit? There's no use. But to ensure that this energy doesn't make its way to source, we are to exhaust it. And when we design electrical circuit, we need to know the exact value of resistance so that it is so in just a position, we don't lose on efficiency either. See for yourself what is happening over here. Let me plot it for you. This is current, right, dear?
Yes.
Okay. What about voltage? Lagging, right?
Yes.
What do? I go back a little, right? Right?
Yes,
Check it out.
So
this is minus x minus vt, so I'll have to go this way. It is here, it goes up, then it goes this way, it goes this way. Check it out.
So won't there be a difference in amplitude? I mean, the current has to be necessarily smaller enough.
Yeah, it can be different.
Okay.
It will be different. Depends on what you're doing. Now look at the quotient which I'm into drawing, this part.
Yeah, you'll
current
get
negative, voltage positive.
You'll get the
current
negative
voltage
power
positive.
there.
This is negative power. And it is recurrent. It is recurrent, correct? It has got a period. So it is to feature with a time interval. This part we need to eliminate. Draw for the case. Combine them. Positive, negative. Positive, negative. See for yourself. Average will always be positive. I'm not talking of average over here. I'm talking of instantaneous power.
So I have a question. If you take a pure inductive or a pure capacitive circuit, then that'll always be negative.
Zero power. That's the reason they are called Watt-less circuit.
So no, if you consider the current and voltage diagrams, they're perfectly out of phase, right?
Yeah, correct.
So you
That's
will,
the reason the product will be zero.
so it won't be zero, it'll be negative.
Which case? When you're talking of instantaneous power.
So no, I'm talking about the general case. It'll always be negative, right? The power will, I mean, you know what I mean, right?
Yeah. Of course it'll be negative.
So
Of course it'll be negative.
I mean,
See, LC when you're talking of, dear, let me take you through this one. Okay. It will never lose current. I mean energy. Energy will be retained. This is L to me, this is C to me. Let us say capacitor was initially charged. What was energy? Q square by 2C. What is now? Let's say some Q by 2C plus of half Li square is equal to energy that was to carry initially. Here, current and voltage both are to oscillate, yeah. Total energy retained. There is no vent to that energy.
so no, I'm talking about when you connect a capacitor and an inductor to an AC source.
Yeah.
So then
Connected?
then it always feels like that always giving back energy. I mean, it's always negative. The power is always negative.
Correct. Because there is no dissipative element in it.
So,
It will store energy. It will store energy. Polarity will keep on changing.
yes, but shouldn't the total power be dissipated be zero? It's like it's generating free energy from nowhere. I mean, what is the meaning of all this negative power?
Negative power means it is the circuit is generating energy. Yes. Circuit has generated energy, or the energy which you did accord to circuit, part of it got reflected. It is back to the source. That is what it means, back to the source. So the circuit is acting source. For that period, circuit is acting source, and source changes its acting to circuit, you may say. Source is
Okay.
changing.
So we shouldn't evaluate this with the inductor in isolation. We should consider this work done by the source and the work done by the inductor.
So the very nature did change here, right? It is no more to claim being source. For that period, it cannot claim source. It cannot stay claim to it. There is a role reversal, you can say, correct?
Yes, sir.
But at the same time, we have to secure source. That is the innate nature. And how can we do that? By placing resistor. If you will not, it will damage source. If you take a purely capacitive circuit, it will damage source, right here?
Yes, sir.
So that is what it means. Over here you saw power. Since I'm in power, I'm not going to LC as of now. Quickly, power if you can check. So you got this, right? Now what we have to do is some mechanical work quickly. Okay. Tell me, dear. Imax done, Vmax done. Okay, bracket open. Sine of the angle omega t. Sine of the angle omega t minus alpha. Imax Vmax, correct?
Yeah, that's right.
Okay, quickly now. Imax Vmax. Some mechanical I do report. Anyway, sine of the angle omega t, cos of the angle alpha minus cos of the angle omega t, sine of the angle alpha. Check it out here. Okay.
Yes, sir.
I max, V max, bracket open, sine is square omega t cos alpha, right? Minus of sine 2 omega t by 2 sine alpha. Do check. I'm skipping few steps over here, right?
Yes, sir.
Okay. Sine 2 omega t, sine cos will get you sine omega 2. Okay.
Yes, sir.
Okay, so I max, V max. Now this will be 1 minus cos 2 omega t by 2 into cos alpha, and this will be sine of 2 omega t by 2 into sine alpha. What do we get? I max, V max, cos alpha by 2 minus cos 2 omega t cos alpha by 2 minus sine 2 omega t sine alpha by 2. Check it here.
Yes,
Yeah?
sir.
Now average, you know, by average what do we mean is P dt by dt average. Now I'm going to average. This was instantaneous. This is instantaneous. Here you can show that power can take negative, positive, 0, all the values, correct? Correct?
Yes, sir.
Now from instantaneous to average, average is this. When you integrate it over period, this factor, this one and this one will tend to 0, will become 0, correct? Check it out.
Yes, sir.
So these become 0. And then what do we get as average power? You can see from here. We get it as I max, V max by 2 into cos alpha. Check it out.
Yes, sir.
That will be the average power, correct? So P average, if I am to write, I will be writing it as I max, V max by 2 into cos alpha. Here is where cos alpha gains traction. See for yourself, there is a term cos alpha here, right? So alpha is gaining traction over here, it's gaining coins. And what is alpha? Coming back to equation, it is the angle between voltage and current, correct?
Yes, sir. So the smaller it is, the more the average power.
Yes, more power you can draw, average power from circuit. And this was used yesteryears by those who were literate on it, particularly the honchos. You know that we have different slabs for different consumption of electricity, correct? If you're consuming high voltage, if you are more into uses inductive circuit, then you are drawing high voltage. And the ones which are connected to your line, they will get reduced voltage. So what do we do, or what they used to do? They used to show that they will be consuming less, their load is less. Thereby, they were beneficiary of being in the lower slot. Lower slot means lesser price per unit. At the same time, they were into cheating by using capacitors. So if you use capacitor, your inbuilt capacitor in factories, you'll be able to gain more power of the same connection, correct? As you'll be reducing cos alpha. So they use capacitor, reducing the angle between current and voltage. They're being beneficiary, keeping the slot low. Subsequently, the charges. It was very much predominant practice. Okay?
Yes, sir.
Okay. And what I was referring to, wattless circuit, of course, if cos alpha is 0, which we will be getting in the case of inductive and capacitive circuit, purely inductive, purely capacitive circuit. In that case, average power will be 0, right?
Yes, sir.
Okay. So this being the case, for power, we'll be throwing more light on the same. Quick now, one more factor I will be taking quickly with you, and that being LC oscillatory circuit. We did a part of it just now, but we will be relating it with mechanics. So I want to rewrite it. Initially, it is Q naught square by 2C. Then let us say Q is it started letting current flow through inductor. So Q square by 2C now plus half Li square. I'm using the energy term. You can use the voltage KVL as well. We can use KVL as well. We're getting the same. Okay, I'll be coming to KVL as well. Differentiated, this becomes 0. This is twice of Q 2C dq by dt plus of half L twice of I di by dt. 2 and 2 gone, 2 and 2 gone. Okay, minus of Q by C dq by dt is equal to Li di by dt. Is gone. Minus of Q by Lc is equal to d2q by dt square. This is what function you're aware of. Nostalgic field, I presume. What is this to indicate?
Simple harmonic motion.
A simple harmonic motion. So not only Q, but also I. I will also be simple harmonic, right? Because when we got Q from there, we'll be differentiating to get I, correct?
Yes, sir.
So both are to us simple harmonic equation. Current and voltage, they will follow simple harmonic equation with what omega? Under root 1 by under root of LC. Please distinguish this omega from resonant frequency. They are different. Okay, the value being same, they being marked same, but they're different. This is resonant frequency of the simple harmonic motion executed by current or voltage. Sorry, yeah, current or let's say charge. More of uses over here is charge, so I'll go to charge. Current or charge. The voltage is also not incorrect, but current and charge. Fine?
Yes, sir.
Okay. So we can plot for it. We will be getting plot and we'll be accordingly getting the phase difference between Q and I. We can easily plot for the same. But before going for the plotting, let me try to relate to what will happen to Q if Q we get as, let's say Q naught sine of the angle omega t. If you'll find an equation for it, it will be Q naught sine of the angle omega t plus phi. This is what we begin with. And at t equal to 0, we have put t equal to 0, I get Q is equal to Q naught. So what we're getting is Q is equal to Q naught cos of the angle omega t. This is a function I'll be getting, correct?
Yes, sir.
Okay. If this is the function omega being known to us, can you tell me there will be a time when charge will become 0, correct?
Yeah.
After charge becoming 0, current will flow or not?
So current will be at its peak when charge becomes 0, right?
Charge becomes 0, current will be at its peak, okay? So current will keep on flowing.
Yeah.
Okay, will current change its direction ever?
So current will change direction, but that will happen when charge is at its peak.
Will it happen when charge is at its peak?
Yeah.
And when charge is 0, at that time it will not.
At that time, it'll have like the maximum momentum, you could say.
So could you please tell me what do you mean by charge being at peak? Can you decode it? Peak means extremum, negative or positive, right?
Yes, sir. The capacitor is fully charged.
Fully charged. It can be with either polarity, correct?
Yeah, either polarity.
Okay. So what we'll do, we'll relate it with this. I presume we can relate it easily with this one. This case, spring K, right?
Yes, sir.
And given a velocity v naught, let us say in this direction, it goes, going, fine. So when it is at its mean position, then its velocity is maximum, correct?
Yes, sir. So that would correspond to the initial condition where the charge was maximum.
Yes. And when charge is 0, current direction doesn't change. Current maintains direction. So when will the direction change? When from plus Q naught, it went to minus Q naught, and this has taken a value plus Q naught. Then direction of current will change, right?
Yes, sir.
So when there is no charge, current is at its peak and current maintains its direction. That is not the position where it changes. It changes later when capacitor is fully charged, be it with reverse polarity. Then again, when the polarity is claimed, it will change its direction. Fine?
Yes, sir.
Okay. So this was about LC oscillation. Can you also relate it with KVL, Kirchhoff's voltage law? This was with energy, KVL, it can be accordingly related, right? How? With KVL, what will I do? I'll write potential equation. So if it is letting the current flow, then this will be the polarity here. Check it out, polarity. This is plus, let us say to begin with, somewhere, some point in time, it is, since it's feeding current to inductor, this is Q, this is plus Q, this is minus Q. Which way shall I take? From plus, if I have to take that, this, let's say this way, right?
Yes, sir.
So what do we get? Minus of Q by C plus of L di by dt, is it? Check it out. From here to here, minus of Q by C, current flowing this way, plus of L di by dt is equal to 0. Whichever way you take, you can take it this way as well. This is plus Q, this is minus Q, then the current is flowing in this direction. It'll be this way then.
So
Right?
when you go from negative plate to the positive plate, shouldn't you take plus Q by C because potential increases
Right.
from the minus Q by C, and then the other one would
This
be
will,
negative. I mean, it doesn't
this will
ultimately
be
matter.
C plus of L di by dt. Yeah, it doesn't. Is equal to 0, right? Is it?
No, LDI by dt would be negative, right? Because across the inductor you have a potential drop.
Yeah. So what do we get? Again the same, L di by dt is equal to what to us? Q by
Minus
C.
Q by C.
And from here we get to the same result, correct?
Yes, sir.
Check it out. Okay, so whichever way you look at it, you're going to get the same result. This is LC oscillatory circuit. Here energy oscillates. We never do get a purely LC circuit, therefore energy is to get decayed or an attenuation, but that is for a very short period of time when can be maintained. It's not that easy to maintain an energy decrement. When you switch off, a simple example, you may be in an anecdotal evidence you can present. What is the anecdotal evidence? When you switch off the light, the LED will not get extinguished immediately. It will take its few seconds moment to enjoy the last fame glory. Right?
Yes, sir. So I think you're talking about the old tube lights. I mean, most of the modern ones just go off once you flick the switch.
The tube lights are different ballgame altogether, dear. Tube lights are having choke. If you're talking of the archaic one, then they used to have choke coil. What is choke coil? Choke coil is high inductive, very high inductive coil. Why were they used? Because we wanted very high voltage for gas to get ionized, but we wanted to secured on energy loss as well. See, voltage high can be gained by resistor as well, right? Yeah. Yes or no?
Yes.
High voltage you can have high resistor, but if you apply high resistor, then there will be loss of power as well, right?
Yes.
So instead of applying high resistor, what we did, we took high inductance. Okay. So choke coil, which we used to get to see yesterday, was nothing but very high inductance coil. Now what we achieved of high inductance? We achieved voltage that we wanted and we secured energy as it will not lose energy. There's only one energy dissipating element, which is resistor, correct?
Yes, sir.
So that is what we have for definition of choke coil. Okay, that's it for the day. Let us keep to this today, shall we?
Yes, sure.
Shitla, what about you? Shall we? Call it a day. I want to stretch for some time.
Ishita, are you there? Yeah. Ishita, who did he
Yes,
ask? What happened?
sir, could you repeat? I didn't.
So your voice is
Are you
breaking.
aware? Okay, fine. Now I'll break off. Thank you. Bye.
Thank you, sir.